On June 1st, U.S. Central Command CENTCOM confirmed it carried out self-defense strikes in southern Iran over the weekend, specifically targeting radar and drone command and control facilities in Goruk and on Qeshm Island. The military action followed the alleged downing of a U.S. MQ-1 drone by Iranian forces, further escalating tensions amid deadlocked diplomatic discussions. Reports indicate that a prized asset has been hit. Chinese origin radar, touted to be capable of detecting stealth aircraft that was deployed on Goruk Island, has been taken down. In this video, Defense Updates analyzes how China-supplied JY-27A anti-stealth radar got destroyed by F-35 in Iran. Before we proceed, a word on NordVPN, which is one of the most trusted and fastest VPN brand that has a no-log policy validated by Deloitte. NordVPN provides a 256-bit encrypted tunnel that protects your privacy and also enables you to access contents that are blocked based on geolocation. Its threat protection system helps you avoid phishing, scams, and malware. NordVPN application is available for all the major platforms as well as browsers. Get an exclusive NordVPN deal with massive saving by going to nordvpn.com/defense or clicking the link in the description. It's risk-free with Nord's 30-day money-back guarantee. Iran has long been concerned about the threat posed by advanced stealth aircraft, particularly the U.S.-designed F-35 Lightning II, which is also operated by Israel. Previous encounters involving stealth platforms exposed significant limitations in Iran's air defense architecture and highlighted the challenges Tehran faces in detecting and tracking low observable aircraft. In 2018, the Israeli Air Force conducted what it described as the first operational combat mission involving the F-35, striking multiple Iranian-linked targets in the Middle East. Reports published by the Kuwaiti newspaper Al Jazeera further claimed that 2 Israeli F-35 fighters flew undetected through Syrian and Iraqi airspace before briefly entering Iranian airspace without being intercepted. The vulnerability of Iran's air defenses was again called into question during Israel's large-scale retaliatory strike on October 26, 2024. The operation, codenamed Days of Repentance, reportedly involved more than 100 Israeli aircraft, including F-35 stealth fighters. Supported by aerial refueling assets, the strike package traveled over 1,600 kilometers, 1,000 miles, to attack more than 20 military targets across Iran. Israeli aircraft reportedly operated deep inside Iranian airspace, including in the vicinity of Tehran, despite the presence of several Russian-made S-300 surface-to-air missile batteries. All participating aircraft returned safely. The operation occurred despite widespread expectations of an Israeli response and heightened readiness across Iranian military forces. While the exact role played by the F-35 remains classified, defense analysts widely believe the stealth fighter was central to the mission. Against this backdrop, reports emerged suggesting that Tehran sought assistance from Beijing to strengthen its ability to counter stealth aircraft. According to a report published by Global Defense Corp on April 22nd, citing U.S. intelligence indicators, American intelligence agencies detected signs that China was considering supplying Iran with JY-27A anti-stealth radar systems during this period of heightened tensions. Separately, CBS News reported, citing assessments from the U.S. Defense Intelligence Agency, that Beijing had explored the possibility of transferring advanced radar systems capable of improving Iran's ability to detect low observable aircraft and complicating future U.S. and Israeli air operations in the region. While no transfer has been officially confirmed, several Chinese cargo planes carrying supplies reportedly landed in Iran in the last few months. The JY-27A is a very high-frequency, VHF, 3D long-range air surveillance and early warning radar designed primarily to detect low observable aircraft. Developed by the East China Research Institute of Electronic Engineering, ECRIEE, also known as the 38th Research Institute of State-Owned CETC, it serves as one of cornerstone of modern air defense networks for the People's Liberation Army. The JY-27A focuses on the VHF frequency band specifically to counter stealth technology. Modern stealth aircraft are shaped geometrically to deflect high-frequency microwave signals, such as X-band or S-band radars used by fire control systems. However, because VHF radar wavelengths are comparable in size to major aircraft structures, like the tail fins or wings, they trigger a physical phenomenon known as Rayleigh resonance or Mie scattering. This resonance drastically increases the radar cross-section, RCS, of the stealth target, making it visible to the radar operator. Operating within the VHF metric wave band, typically between 240 MHz and 390 MHz, JY-27A is specifically optimized to exploit structural resonance in low observable targets. While unverified, some reports suggest it has a maximum detection range of up to 500 kilometers, 310 miles for conventional aircraft, and 300 kilometers, 186 miles, against stealthy platforms. The entire system is engineered for high tactical mobility, utilizing heavy military truck chassis to allow rapid deployment and quick pack-up times that help the crew evade anti-radiation missiles and counter battery strikes. While no details have come to public domain regarding how the radar was taken down, we have to examine several aspects. First, it is important to recognize that China has yet to demonstrate the combat effectiveness of a stealth fighter on the scale achieved by American fifth-generation aircraft. This raises legitimate questions about the real-world performance of Chinese anti-stealth radar systems and the extent to which they have been validated against genuinely low observable targets. While the Chengdu J-20 is officially classified as a fifth-generation stealth fighter, some defense analysts argue that its stealth characteristics and overall design philosophy place it closer to an advanced 4.5-generation platform than to aircraft such as the F-35. Viewers may also note recent developments involving Yang Wei, the chief designer of the J-20. The Chinese Academy of Sciences removed his online profile, making his biography inaccessible through official channels. Yang, a key figure behind China's most advanced fighter program and a former senior executive within the Aviation Industry Corporation of China, appears to have been caught up in the broader anti-corruption campaign that has increasingly affected China's defense industrial sector. At the same time, reports have suggested that domestic radar developers have used the J-20 as a benchmark platform when evaluating anti-stealth detection capabilities. Some assessments indicate that the aircraft may be detectable under certain operational conditions. So the question is, if a country doesn't have a proper low observable aircraft, can an anti-stealthy radar developed by it be any good? Second, the F-35 possesses multiple options for neutralizing radar sites without entering their effective engagement envelope. One example is the AGM-158 Joint Air-to-Surface Standoff Missile, JASSM, which has a range of approximately 370 kilometers, 230 miles, while the extended range AGM-158B JASSMER can strike targets at distances approaching 926 kilometers, 575 miles. These weapons enable launch platforms to remain well outside the coverage area of many ground-based air defense systems. In addition, the AGM-88G, Advanced Anti-Radiation Guided Missile Extended Range, has been specifically designed to locate and destroy enemy radar systems. The missile is believed to have a range exceeding 300 kilometers, 186 miles, allowing it to target air defense sensors from significant standoff distances. Third, even if the JY-27A succeeds in detecting an F-35, detection alone does not guarantee a successful engagement. There is a critical distinction between initial detection and generating a continuous engagement quality track capable of supporting missile guidance. Achieving such tracking becomes substantially more difficult in a heavily contested electromagnetic environment where electronic warfare systems are actively degrading radar performance. Fourth, even assuming the radar can provide reliable tracking data, another question remains. Does Iran possess the integrated air defense architecture and missile systems capable of exploiting that information to successfully intercept a fifth-generation fighter? Detection, tracking, target handoff, missile launch, mid-course guidance, and terminal interception must all function seamlessly for a successful engagement. So, while the JY-27A may represent a valuable enhancement to Iran's air defense network, it should not be viewed as a silver bullet against stealth aircraft. Modern air combat depends on the integrity of the entire kill chain, and an adversary needs to disrupt only one link in that chain to significantly reduce the effectiveness of the system.